So today we're going to talk about enthalpy, entropy, and free energy. So these are all different terms, and they all have different letters that represent them. So make sure you are able to distinguish between all three of them. So the first one is enthalpy, which we've already spoken about, and that is delta H. So enthalpy is your heat of your reaction. So that is delta H is equal to the heat of the products minus the heat of the reactants. Next we have S. S stands for entropy, and this is a way to measure the degree of randomness in particles in a system. So entropy basically tells us if we're going to a more random system or a less random system. So when we think about it, gases are more random than solids are. That's basically what it's talking about here. Next one we have is G, and that's free energy. And our free energy is a factor that takes into account both our enthalpy, our entropy, and our temperature to determine if our reaction is going to be spontaneous or not. Spontaneous means, is it going to happen? Okay, so like I said before, delta H was your enthalpy. We see this little knot right here. So this little 0 up on the top, it looks like a degree sign. That means it's based on a molar value. So we've already talked about moles. So this is telling us for 1 mole of the substance, of the reaction, whatever it is, when you see that little knot there, you know that you're talking about a molar value. Okay, so if you get delta H molar, and that's positive, that's going to be an endothermic reaction. If you have delta H molar that's a negative, that's going to be an exothermic reaction. So we've already talked about the heat. So if we have a positive heat change, that's endothermic. If we have a negative heat change, that's going to be exothermic. So when we're using this, we're usually going to see our delta H value as the units of kilojoules instead of just joules. Because when we're talking about heat, usually we have very large quantities of heat. So if we put it in kilojoules, we don't have to write as many zeros at the end. So these two equations right here, these are two ways that you can see our delta H shown to us. So at the end of an equation, it could just say delta H is equal to. But more often than not, it's going to be within your equation. So for example, here we have H2 plus Br2 plus 72.80 kilojoules goes to 2 HBr. So here, we're saying that this heat amount is being added to the reactants. When that is the case, this is going to be an endothermic reaction, meaning that delta H is going to be positive. So it's being added to the reactants. That means that our products have more energy than our reactants did. For this one, we have 2P plus 5Cl2 goes to 2PCl5 plus 886 kilojoules. Here we're saying that our products have, our reactants have given off heat. So one of our products is going to be heat. So this is going to be an exothermic reaction. Exothermic. So delta H in this case is going to be negative. So you're going to have to come familiar with if our heat is on our reactant side, that's endothermic. If our heat is going to be on our product side, that's going to be exothermic. Okay, so let's look at this problem right here. How much heat will be released when 6.44 grams of sulfur reacts with XX oxygen according to the following equation? So we have 2 sulfur plus 3 oxygen goes to 2 SO3. So it's telling us that our heat of the reaction, so our enthalpy change is negative 791.4 kilojoules. First, is this going to be exothermic or endothermic? We have a negative, so that means it's going to be exothermic. Okay, so what they want to know is how much heat will be released with 6.44 grams. Right now, when we have this reaction, we're not dealing with grams. We need to put in our grams. So this right here, this is going to go back to our conversions. I told you we're never going to stop using them, and here's a good example. So we're starting with 6.44 grams of sulfur. Like I said before, when we have this little knot up here, this means that we're talking about molar. So the first thing we're going to want to do is get our grams into moles. The way that we do that is we use our molar mass of sulfur to get this into moles. You guys already know how to do this. So the molar mass of sulfur, where did that go? Here it is. The molar mass of sulfur is 32.07. Okay, now what we have to do, when we look at sulfur, which is right here, the coefficient in front of it, is telling us how many moles of that substance are being reacted in this equation. So here we have 2 moles of sulfur. So we're going to be putting that on the bottom. Next we have to do, what we're trying to find is our heat. So we have to put our heat up on top. So now we're starting with 6.44 grams of sulfur. We're getting that into moles using the conversion that we've learned. Then we're trying to figure out the heat of this reaction given 6.44 grams. So we have to multiply that by the heat and divide it by 2 moles because that's the amount of moles that were present in this equation. So that is going to give us a value of negative 79.46 kilojoules. It's kilojoules because we have grams with grams, moles with moles, and we're left with kilojoules. Okay, so now we have to make sure we have the correct amount of significant figures. So here we have 3, here we have 4, so this needs to be to 3. So that's going to be negative 79.5 kilojoules. Oops. Okay. How much heat will be released when 4.72 grams of carbon reacts with excess O2 according to the following equation? So we have carbon plus oxygen goes to carbon dioxide. And we are told that our molar enthalpy is going to be negative 393.5 kilojoules. What I want you to do is I want you to try this one on your own. See if you can get it. Here's the answer right here. We can go over it in class next time. Okay, so the next equation that we're going to be talking about now is our free energy. So we already talked about G. So delta G molar is equal to our molar enthalpy minus temperature times entropy. So this equation is basically telling us if a reaction is spontaneous or not. If we get our delta G to be negative, that means that it is a spontaneous reaction. Basically what we want is for our reaction to go to lower energy. Reactions always go to lower energy. When that occurs, it's spontaneous. If our free energy is positive, that's a not spontaneous reaction. We can make it happen, but it doesn't happen under normal conditions. Okay. Alrighty. So this chart right here tells us if our reaction is going to be spontaneous or not, based on our delta H and our delta S and our temperature. So if we have a negative delta H and a positive entropy, we're going to have a spontaneous reaction. If we have a negative delta H and a negative entropy, it will be spontaneous only at low temperatures. So you have to think about this as plugging it into the equation. So we have a negative delta H here, and we're going to have a negative delta S, The only way that it's going to end up being negative, since we have a minus sign, is if this temperature is really low. If we have a positive delta H and a positive delta S, when this temperature is high, it's going to be spontaneous. Now if we have a positive delta H and a negative delta S, it is never going to be spontaneous. So make sure you copy this chart down. Alrighty, here's an example problem. NH4Cl, 5, that's a 5, goes to NH3, and then in parentheses right here you see G, this means it's in a gas form, plus HCl, which is also in a gas form. It's telling us that the temperature here is 298.15 Kelvin. Then it's telling us that the molar enthalpy is 176 kilojoules per mole. And it's telling us that the molar entropy is 0.28 kilojoules per mole degree Kelvin. What they want us to do here is they want us to calculate delta G and see if this reaction can proceed in the forward direction. So if it can proceed in the forward directions, that's telling us that it is spontaneous. Okay, so our equation here is delta G is equal to delta H minus temperature times delta S. So what we're going to do now is we're just going to plug this in. So it's told us that our delta H was 176 kilojoules per mole. And that's going to be minus our temperature, which is 298.15 Kelvin, times our molar entropy. So make sure when you're plugging this into your calculator, you do these two multiplied, and then do this minus all of this. Alright, so when I plug it in, I get 91.027, but let's see, we have 3, 3, 4, so this needs to be to 3 significant figures, so 91.0, and this is going to be kilojoules per mole. Okay, now we have to see if it's going to proceed in the forward direction. We have a positive delta G, so if it's positive, this is not spontaneous. Okay, this next one I want you to try on your own. Carbon plus oxygen goes to carbon dioxide, and we're adding 393.51, I should say, kilojoules. So this is like what I showed you before, that you have your enthalpy within your reaction. So you have to know that because this is on your product side, it's going to be an exothermic reaction. So if you know it's exothermic, you have to decide if this value is going to be positive or negative. They give you temperature is 298.15 Kelvin. They tell you that your entropy is 0.00300 kilojoules per mole. And what they want you to do is they want you to calculate delta G and say if it's spontaneous. The answer is right up here, so negative 393 kilojoules per mole, and it is spontaneous. Try to work this out and make sure you get the right answer. We can go over it in class next time.